So this question with a baby bouncer involves vertical simple harmonic motion. And although we don't have a spring, we have a harness and elastic ropes which probably behave like springs. So we have some doorway and we have some arrangement where we have springs or elastic attached to a harness, and we have a baby in there, and the baby is vibrating or oscillating up and down, bouncing up and down around some equilibrium position. Now, we know the mass of the baby, and we know that there's an initial stretch from the equilibrium position. So there's probably an equilibrium position, and when the baby was put in, there was a slight stretch. So if we treat the bouncer as a spring, we can say F equals K delta L, and we can find the spring constant of this elastic rope. So it's simply F divided by the extension. And F will be the weight, and the extension is given. So it's 10 times 9.81 divided by 0.25. So that gives you 392 Newton per meter. So that's my value for K. And I'll use that to find the period of oscillation. So if we model it as a spring, that's the trick, I think. You treat this as if it were a spring. It isn't a spring, but you can pretend it was a spring. Think of it as a spring. So the period, the time period of a spring is 2 pi square root of m over k. So m is the mass of the baby, that hasn't changed, and k is what we've just found. So you can substitute those numbers, and that will give you 1 second. So the baby will be going up and down, down and up 1 second. So a frequency of 1 hertz and a time period of 1 second.